Functions are quite important in mathematics and in computer science. So we actually start using functions before we define the notation for functions. And so let me show you, start out in the middle here, the notation of functions. So f of a is we take an input a, we apply a function, and we return some result. And that's going to be what f of a is going to be. The function, when we want to refer to the function itself, we refer to the function as taking inputs from a set A and producing outputs in a set B. So with inputs from a domain and outputs to a range. And you can, of course, click on these numbers over here to jump to the definition in the textbook. Now, we started using functions for counting earlier on. So factorial was one function. It takes an integer and gives back an integer that is much bigger. N to the r falling is the same as P and R. It's the number of permutations of n things if we choose R and are not allowed to make repeats. So ordered matters, repeats are not allowed, is counted by P and R. Binomial coefficients, all three of these notations are used. In choose R with the parentheses, as well as NCR is on some calculators, or C of NR is sometimes used for choose. This counts sets. If we have n items, no repeats, order doesn't matter, we choose R of them, the number of ways to do that is n choose R. Those were the ones that we defined, used before we defined the function notation. In defining function notation, there's also composition of functions, where we apply one function and then another, indicated by circle, to make the new function from the two old functions. And then here are some very common functions that we've used. Square root, log, both base 2 and natural log. LG is the one that we use most often in computer science, the log base 2. Mod is the remainder function, so it's like dividing, except instead of getting the answer, you just get the remainder. And greatest common divisor, GCD, is the greatest number that divides both A and B. Those are some example functions.